So good day everyone, I'm Decadent Dave Habadan and we are the group 5 and we are assigned to share and discuss the application of error to a compass. So here's a members, Decadent Java, Decadent Humawan, Decadent Dave, and Decadent Ebarita. So let's start with the application of error to a compass. So the compass and the bearings laid on a chart are true, but we steer courses and take bearings using a compass. The compass used in small vessels is more commonly a magnetic compass, although some may be fitted with a gyro compass. It is suggested that this section be read in conjunction with learning outcome 7 on a magnetic compass and azimuth circle. Firstly, we will deal with the magnetic compass and the errors involved. The difference between direction as measured by a compass and the true direction as measured on a chart is termed compass error. Stated differently, it is the angular difference between true north and a compass north. It is named east or west to indicate the side of the true north on which the compass north lies. So, the next slide illustrates the figure which is the direction of a compass error. So as you can see in the illustration, the compass error is a combination of two separate and distinct components, namely viration and a deviation.
Good day, everyone. I am Decadent John Simon Hava. This is the continuation report of Dave Habadan. So, variation. When influenced only by the Earth's magnetic field, a compass needle will point towards the Earth's north magnetic pole. This pole is located somewhere to the north of Canada and is slowly moving. Examination of a globe will show that from a position on the east coast of Australia, the compass will point in a direction to the east of true north. This is magnetic north, and the angle between it and true north is called variation. In our case, variation is east. So, to find the value of variation for any position, simply consult the nearest compass rows on a marine chart. The variation will be given for a specified year, together with the rate of change, allowing calculation of variation for any subsequent year. See appends for variation chart of the world. So example, chart OS 823 gives the following information in the compass rose to the south of Street Beach Island. So the magnetic variation is 8 degrees 40 minutes east, increasing about 2 minutes annually. So, in 1997, the variation will have increased by 2 minutes each year for 18 years, a total of 36. Adding this to 8 degrees 40 minutes, we find that the variation for 1997 is 9 degrees and 16 minutes east. Now, we will consider deviation. In the unlikely event that the vessel is constructed entirely from non-magnetic materials and has no electronics close to the compass, variation is the only error which will need to be accounted for. In all other cases, the vessel and or its equipment will create magnetic fields of their own. Some of these will be built into the vessel on the slip. Others will change as the vessel moves around within the influence of the Earth's magnetic field. So the compass adjuster is usually able to reduce the effect of the vessel's magnetic fields, but the causes are so complex that it is inevitable that some effects remain. For the ship's compass to work at all, the effect of the ship's magnetism must be less than the force of the Earth's magnetic field. To illustrate the effect of the vessel's own magnetic field, imagine a vessel on which the compass needle is attracted towards the stern. When the vessel is heading towards magnetic north, the effect of the pull towards the stern is to reduce the directive force at the compass but not to deflect it from magnetic north. As the vessels turn onto easterly headings, the compass needle is deflected towards the stern, towards west. When the vessel heads west, the compass needle is deflected to the east. There will be no deflection when the vessel heads south, but an increase in directive force. This deflection of the compass away from magnetic north is called deviation. As with variation, it is named east or west, and the value will change according to the ship's heading. A deviation card is produced by the compass adjuster when the vessel is first commissioned at and at intervals throughout its life. It is displayed close to the compass position. An example of a deviation card can be found on page 78. This relationship between compass, magnetic, and true course and bearings is shown in the following diagram. So as you can see in the picture, this is the relationship between compass, magnetic, and true courses and bearings.
Hey sir, I'm Deck Cadet kay Sir Romy Verita. Rules for applying variation and deviation. To avoid drawing diagrams, every time variation and deviation are applied, a number of memory aids have been developed to clarify the rules of application. Television makes Dahl Company, TBMDC, reminds us that we must apply the variation to find magnetic, and to this we apply deviation to arrive at compass, course, or bearing. If we start with a compass bearing and wish to convert is true so that it can be used to the chart, the order of operation is reverse CDMBT. Having decided the correct order in which to apply variation and deviation, we need to know whether the correction should be added or subtracted. This may be decided using word cadet. This simply indicates that to get from compass to the endpoints we add east. Given that we add east, deviation or variation, it follows that we must subtract west, deviation or variation. It also follows that if we add east to get from the compass true, we should add west when going from true to compass. A simple layout for applying these rules is shown on the next page. Compass error. If we expect to take several bearings while steering the other steady course, it makes good sense to arrive at the single corrections to apply all those bearings, remembering that the variation remains effectively the same whilst operating in the one area, that deviation will only change when we change course. We find the compass error for the course being steered and apply that all bearings taken whilst on the course. Example, we are steering 0.7 degrees Celsius. The deviation from the deviation card for 0.7 degrees is 3 degrees west, and the variation from the chart is 11 degrees east. The compass error combined variation and deviation. Therefore, 8 degrees east. Since we are converting compass bearings to true, we added east cadet. Therefore, while steering 0.7 degrees Celsius, add 6 to any compass bearing to convert it to true.
Hi everyone, I am Alden Umawan and I will continue the report. So, simple layout for variation and deviation. Deviation is taken from deviation table at the end of this section. So, one is changing from compass to true. So, the compass course is 215 degree and the deviation is 6 degree, and magnetic course is 209 degree and the variation is 11 degree, and the true course is 220 degree. Number 2 is changing from true to compass. So the true course is 220 degree variation is negative 11 degree, magnetic course is 209 degree, the deviation is 5 degree, and the compass course is 214.5 degree. So next is, for most practical purpose, this compass course is sufficiently accurate, but to be strictly correct, we enter the deviation table with a compass course of 214 degree. Rather than the magnetic course of 209, in this case, deviation would be 6 degree and the total working as follow. So, the true course is 220 degree and the variation is 11 degree. The magnetic course is 209 degree. The deviation is 5.5 degree and the deviation is 6 degree. Compass course is 215 degree and 214.5 degree. The difference is surely like to be great, but beware a deviation card which indicates rapid changes in deviation. When working with bearing, the same layout is followed, but remember that deviation tables is entered with ship head, not bearing.